Hi, welcome to the Quick History Workshop. In my previous video I showed you how all the parts were welded and prepared by my good friends Neil Etheridge and his team, and I was very happy with all the parts. They came out really well. So I loaded everything in my car and it fit in the back of my little car and drove the way back home, and everything was there. So this parts that there was parts that needed to be engineered, and here you can see some of those parts. This aluminium, it was laser cut roughly and then machined to be exact. So the bearings must fit in that space there between these two blocks, and then it gets pinched in there, and this must be a very precise fit so that there's no chance of the bearing spinning in there or any chance that the bearing will not function correctly. Drilled holes through the aluminium to fit threaded rods through. These rods will pull it together. So the base plate was also laser cut, but because of the thickness of the aluminium, the laser cut company couldn't cut the holes in. So they just made scoring marks for me, little crosses, and I have to drill them myself. So I'm doing a little bit of punching here just to make sure that the drill is centered correctly on the marks, and take it away to be drilled on my drill press. I must make note of each hole must be a different size correctly according to my drawings. So these big holes, it gets tapped, they are for the bearings. Some of the holes are just to tie it to the main structure, and some of the holes are to hold the gearboxes. Some of the holes gets tapped, some of them gets countersunk, and some of them gets just drilled. So here I'm finished with all the drilling. Here are all the parts for the base and the legs. As you can see here, those holes. So we're going to assemble them so that we have a frame. We also, this is that part. The rotor turns around this way and throws the water over, and then it can't flow back because of this. These are the machined parts for the bearings. A big thanks to Reids Engineering, Allan and Rodger, that did a wonderful job with the machining of this. They had to drill holes through and machine that and just mold it all around. So a square brass nut comes into this hole. These are the square brass nuts that goes into the hole, and this is the threaded rod goes into the gearbox. So that's also machined down to fit into the gearbox. These are the brass nuts. It's 25 by 25 millimeters brass. That's machined, and that must go into that square hole there. So it's a very tight fit, and I don't want to damage anything. So I'm gonna heat up this part and put this part in the freezer actually. So if I make this cold and I heat up that one, it will go in easily. That hole is just the way it came from the laser cutters. I filed it a little bit. You can see it's not machined, it was just laser cut into the aluminium. So here I'm putting an extra nut in. The part is still warm. This nut is just to keep the grease in. What I'll do is I'll press it in. It's a tight fit, and I'll match up the thread with the brass. As I put the threaded rod in, I can rotate this nut so that the two threads is synchronized. So this thread here, this nut that I machined to fit in there, is purely just to keep the grease in that pocket. And this part is finished. Here is the finished tub, nicely polished. And then this is the rotor. These blades go in like that all around. But the assembly of the rotor is for next week.
This base plate with the gearbox, you saw me drilling and making the holes for this.
So what happens here is there's a little shaft that goes between these two gearboxes, and then these gears, they get welded on the shaft, and then there's an input on the one side that drives this, and then the other side will drive the counter, so that you know exactly how much up and down the rotor goes. And it's driven by a little hand wheel, this hand wheel. So you get a shaft on the one side and output on the other side with the counter. So after we assemble these legs, what I'll have to do is move this into place underneath the tub, that those holes line up with this. It gets bolted in here, and then I have to project this shaft. I didn't laser cut holes into the front here because I wasn't sure about the exact point of exit. However, I'm updating the laser cut file so that these holes will be there. If my shaft goes in here and everything is lined up, I'll have to make a hole through this front here in order for me to locate the place where the hand wheel will be. And there's a bearing also here that supports the hand wheel. So all of that needs to be
sorted out after this is installed. So for now we're just going to assemble these legs and the frame.
Here I'm using Loctite on the bolts that holds the gearboxes, because when these gearboxes are installed, the bolts gets covered by the tub, and I don't want anything to rattle loose. You can also clearly see underneath the gearboxes there are two spaces that was also laser cut and drilled according to the plans. Here you can see we assembled the wheels and the frame, these bolts. They are button head Allen bolts, and I've also installed this little box for the the switch. This part was not laser cut, and also I added this extension plate that I will modify the files for, because I wanted a bigger plate there for these bearings, and this bearing fits on this side and for the one side, and on the crank wheel side I've engineered a bush, so there's a bearing and the bush. I don't want any strain on the counter, so it is a good thing to have a separate bearing for that shaft. And also I want the hand wheel to be very smooth and stable, so from that side I use a piece of engineering plastic. It's a self-lubricating nylon, and we can turn it all right side up now, and I'm inserting this bracket. This bracket will be something that I can weld the tub on. I can't weld stainless steel to aluminium, so I need something there. So it's all ready to receive the tub on top of this assembly.
These are the gears that I had laser cut. It's 4mm stainless steel, and what I do is I put it in the lathe like that with a nut, and then when I spin it, I take my grinder and I just take the corners off, so that it's got that profile. You can see there at the top. This is for the chain.
Here I'm getting ready to weld all the sprockets to the shafts, and you'll see I'm doing quite a bit of welding. I'm using a stainless steel welding rods. I don't have a TIG welder, so I'm just using arc welding, but these rods are very, very, very good, and they do a very, very good job of welding stainless steel to stainless steel. Now it's time to fit the chains, and I already calculated more or less the right distance before I did the assembly. So all I need to do is I need to measure how long the chain must be. And I'm cutting the chain to length and then I'm just joining it again. This is a little bit of a tedious operation, so I'll spare you this. And finally, it's time for me to insert these bearing blocks. I just need to align the keyways and tap this in place. What I'm doing here is I'm turning the gearboxes so that they align with the keyway in the shaft, and then just tapping it lightly a couple of times, goes in, and then insert the key from the bottom. And for those of you who don't know what a key and a keyway is, this short clip here illustrates. So we have the outer part. In my case, this would be my gearbox hollow shaft, and we've got the shaft, and they have these slots cut in them. So when I put the parts together, I made sure that they align, and then after they align, I can insert the key like that, and then the two parts rotate together. They're locked. Thank you for watching. I hope you have a great week, and next week we'll do the rotor and fit the motor. Here's some extracts to look forward to.